Hello students, today we are going to discuss JEE Main 2025 questions from most important chapter Wave Optics January attempt. We are going to discuss all the questions in detail, and also we have a page in Instagram and WhatsApp channel. In WhatsApp channel we have a complete discussion regarding physics, so do join in the channel to explore more regarding physics. And also to watch more video like this, don't forget to subscribe our channel. Let us see the questions. We'll see the first question. Assertion in Young's double slit experiment is performed in an optical denser medium than air, then the consecutive fringes come closer. First, we'll compare these two medium. First one is air, which you call it as rarer. Second one is denser. So, compared to the denser medium, in the case of rarer medium, wavelength and velocity will be maximum. In the denser medium, wavelength and velocity will be minimum. Okay, so here they have compared fringes. Because of that, I'm going to take fringe width formula. Beta is equal to lambda d by d. So we can know that beta is directly proportional to the wavelength. So in this question, instead of air medium, they have chosen denser medium. In the case of air medium, wavelength is maximum. Because of that, fringe width also will be maximum. Coming to the denser medium, since the wavelength decreases, the fringe width also will decrease. So if fringe width decreases means all the fringe will come closer. So assertion is correct. Okay. So coming to the reason, the speed of light reduces in an optical denser medium than air while its frequency does not change. So reason also correct. So when the light travels from air medium to the denser medium, wavelength and velocity will change because velocity is directly proportional to wavelength, but frequency remains constant. Okay, so the reason is also correct. So we can check the option. Both assertion and reason are true, and reason is a correct explanation of A. So option 1 is the right answer. We'll see the second question. Statement 1. Fringe width of red light is more than fringe width of violet. So for that, first we'll take Vibgya. Okay. And we know red color has a longest wavelength. So wavelength of red is maximum. And for violet, wavelength is minimum. So they have compared with fringe width. For fringe width, in previous problem, we have seen a relation. Beta is directly proportional to lambda. So for red, the wavelength is maximum. So fringe width will be maximum. For violet, wavelength is minimum. So fringe width will be minimum. So we can write it as fringe width for red color is more than fringe width for the violet color. So we can say the statement 1 is right. So coming to the statement 2, fringe width is directly proportional to the wavelength. So that relation is also correct. So statement 2 also correct. So we can check the option. Option 2, both statement 1 and 2 are correct. Option 2 is the right answer. We'll see the next question. If width of the one of the two slit in Young's double slit experiment is D, while that of other slit is XG, if ratio of maximum to the minimum intensity in the interference pattern on the screen is 9:4, what is the value of X? So first we'll take the given data. They have given the width of the slit. So W1 is equal to D and W2 is equal to XD. And also they have given the ratio of maximum and minimum intensity. So I'm going to take the formula with respect to maximum and minimum intensity and width of the slit. So I maxima is equal to W1 plus W2 the whole square, and for I minimum that is equal to W1 minus W2 the whole square. So they have asked in the form of ratio. So I'm going to divide this to equation. So I maxima and I minima is equal to 9/4. That is equal to, in the place of W1 we can substitute D plus XD the whole square. The place of again W1 D minus XD the whole square. So here you have square. I'm going to take this square to the opposite side. So it will become root. So we can write it as root 9 is 3, root 4 is 2, 3/2 is equal to, we can take D as common. So D, if you're taking common, means D into 1 plus X, and denominator also D into 1 minus X. So D will get cancelled. So if you cross multiply, it will become 3 minus 3X, that is equal to 2 plus 2X. So I'm going to reform this equation. If you're taking 2 to the opposite side, 3 minus 2 is 1. That is equal to, if you are taking minus 3x to the opposite side, it will become 5x. Okay, so we can take it as x is equal to 1/5. So actual value is x is equal to 1/5, but in option we have only 5. So it's a bonus question. If you attend this question, you will get the mark. So anyway, the answer is x is equal to 1/5. Next question, in Young's double slit experiment apparatus is immersed in a liquid of refractive index 1.44. It has a slit separation 1.5 millimeter. That is, they have given the refractive index and the slit separation small d. The slit are illuminated by a parallel beam of light, where the wavelength in air they have given lambda 690 nanometer. Fringe width on screen placed behind the plane of a slit at the distance 0.72 meter. That is, they have given the distance between slit and screen will be, they have asked fringe width. So with respect to medium, we have to write the fringe width. So fringe width general formula, beta is equal to lambda d by d. Suppose they placed in another medium, so we can write it as lambda by refractive index. That's all. So we'll substitute the value beta is equal to, in the place of lambda, we can substitute 690 nanometer, which is 10 power minus 9, and capital D is 0.72, and refractive index is 1.44, and the width of the slit, that is the slit separation, is 1.5 millimeter. So we can write it as 1.5 into 10 power minus 3 meter. So if you calculate this value, you'll get the answer as approximately 0.23 into 10 power minus 3 meter, which you call it as 0.23 millimeter. So we can check the option. Option 1 is the right answer. Next one, the Young's double slit interference experiment performed using consists of 480 nanometer and 600 nanometer to form the interference pattern. The least number of bright fringes of 480 nanometer that required for the first coincidence with the bright fringes formed by 600 nanometer. So they have given two wavelength, that is 600 nanometer, and second one is 480 nanometer. They asked least number of bright fringes that coincide on 600 nanometer. So first we'll take number of fringes on 600 nanometer is n. So here we can take it as alternate, that is n plus 1. Okay, so the relation is n lambda 1 that is equal to n plus 1 lambda 2. So we'll take lambda 1 as 600 nanometer. So we can substitute n into 600 nanometer is equal to n plus 1. Lambda 2 is 480 nanometer. So nanometer will get cancelled. 0 will get cancelled. We can write it as 60 n is equal to 48 n plus 1. Okay. And now we will do the calculation. So 60 n is equal to 48 n plus 48. So if we are taking 48 n to the opposite side, it will become 12 n is equal to 48. So if we are cancelling in a 12th table, so n is equal to 48 by 12, that is equal to 4. Okay. So the number of fringe formed on 600 nanometer is 4, but they asked for 480 nanometer. So that will become 4 plus 1, that is equal to 5. So option 4 is the right answer. Next question. In the Young's double slit experiment, the distance of the 10th bright fringe from the central maxima is 10 millimeter when the light of wavelength used is 600 nanometer. So in first condition, they have given the distance between central maxima and 10th bright fringe. So x, that we can take it as x10, that is equal to 10 millimeter. The wavelength used in the experiment, lambda, is equal to 600 nanometer. Okay. And next, find the distance of the 10th bright fringe from the central maxima if the light of wavelength 660 nanometer is used. So instead of 600 nanometer, if you change the wavelength to the 660 nanometer, what will be the position of the 10th bright fringe? That means we have to find the x, we can take it as x dash. So they have given the bright fringe, so we can take the formula xn is equal to n lambda d by d. So in the both the condition also they have used only 10th bright fringe only. So we don't want to consider n will be same, that is 10. And we don't want to consider capital D and small d because they didn't give. They have changed only the lambda. So we can write the relation x is proportional to lambda. In the case of first condition, the x is 10 millimeter and wavelength used in that experiment is 600 nanometer. So that is proportional to 600 nanometer. And coming to the second condition, we have to find the position x dash, that is proportional to wavelength 660 nanometer. Now we can take the ratio. If you're taking a ratio, nanometer will get cancelled, 0 will get cancelled. Balance 10 millimeter by x dash is equal to, if you're cancelling means 60 by 66, it will become 10 by 11. So we can write it as 10 by 11. 10 will get cancelled. So we can write x dash is equal to 11 millimeter. So answer is 11 millimeter. Next, it's a direct theory question. Which of the following phenomena is not explained by wave theory of light? That is Compton effect. So, Compton effect is not explained by a wave theory of light. Option 4 is the right answer. Next question, in the following diagram, polarized P1 and P2 are orthogonal and P3 is aligned at 45 degree with respect to P1 and P2. If the unpolarized light of intensity I0 is incident on P1 and P2, light after passing through P3 is used in Young's double slit experiment. So initially there is an unpolarized light behind P1 and P2. So whenever unpolarized light passes through the polarizer, it will become polarized light. Because of that, the intensity will become half. So initially the unpolarized light intensity is I0. After passing through P1 and P2, it will become polarized. Because of that, the intensity will become I0 by 2. Okay. And again it passes through the polarizer P3, which makes an angle 45 degree. So we have to find the resultant intensity after passing through P3. So to find that, we can use the formula I is proportional to cos square theta. So I is equal to, instead of constant, we can substitute the previous intensity value, the I0 by 2 into cos square. In the place of theta, we're going to substitute 45 degree. So 45 degree, that is equal to I0 by 2. Cos 45 is 1 by root 2. If you're taking square means, it will become 1 by 2. So that is I0 by 2. So the intensity after passing through polarizer P3 is intensity I0 by 4. Okay. Now this light passes through the Young's double slit experiment. So we have to find the resultant intensity at point P, which has a path difference lambda by 4. So they have given path difference. With respect to that, we have to find the phase difference. So to find the phase difference, we can use the formula. Phase difference is equal to 2 pi by lambda into path difference, that is equal to 2 pi by lambda. In the place of path difference, we can substitute lambda by 3. Lambda will get cancelled. So 2 pi by 3, we can take it as 120 degree. So we know the phase difference, and to find the resultant intensity, we can use a formula, that is I resultant is equal to 4I cos square 5 by 2. Okay, now we'll substitute the value, that is equal to 4. In the place of intensity, we can substitute I0 by 4, that is I0 by 4 cos square. Pi is phase difference, that is 120 by 2. This will become 60. This 4 will get cancelled. Balance I0 into cos square 60. Cos 60 is 1 by 2. If you are taking square means, it will become 1 by 4. So the resultant intensity is equal to I0 by 4. We'll check the option. Option 3 is the right answer. We'll see the next question. At the interference between two materials having refractive index N1 and N2, the critical angle of reflection of EM wave is theta 1c. So for this, we'll go in the form of diagrammatic way. So they have given two medium N1 and N2. So it undergoes a critical angle, so that the light has to travel from denser to the rarer medium. The light travels from denser to rarer medium and undergoes a critical angle. So the ray will be from denser to rarer. It will pass through surface of separation, so it will make an angle 90 degree. So this angle, they call it as a critical angle. In question, they have given it as theta 1c. For this, we will write the equation. So light travels from denser to rarer. So refractive index N2 into sine theta 1c, that is equal to, and rarer medium, the refractive index N1 sine 90. Okay, so sine 90 will become 1. We can write it as sine theta 1c is equal to n1 by n2. Okay, so this is the first condition. Coming to the second one, if n2 material is replaced by the another material having refractive index n3, suppose the refractive index is changed to n3, so the critical angle will change, right? So the critical angle is theta 2c. So now the critical angle is theta 2c. Okay, they have given the relation between n2 and n3 and the critical angle relation. So we have to find what is the critical angle for first medium, that is theta 1c. Okay. So now we'll write the equation for the second medium. If the refractive index of the medium is changed to n3, so we can write it as n3 sine theta 2c is equal to, again the rarer medium has the same refractive index n1, so n1 sine 90. Again sine 90 will become 1. So we can write it as sine theta 2c is equal to n1 by n3. In this question, you can see they have subtracted these two angles. So here also I'm going to do the same. So I'm going to take sine theta 2c minus sine theta 1c. So sine theta 2c minus sine theta 1c is equal to n1 by n3 minus n1 by n2. Okay, so this they have given it as 1 by 2. So I'm going to substitute as 1 by 2. So 1 by 2 is equal to n1 by n3 minus n1 by n2. And they have given n2 by n3 is equal to 2 by 5. So here I am going to multiply and divide by n2 by n2. So we can write it as 1 by 2 is equal to n1 by n2 into n2 by n3 minus n1 by n2. So here we know what is n2 by n3, which is 2 by 5. So 1 by 2 is equal to, I'm going to take n1 by n2 as a common balance in the place of n2 by n3, which is 2 by 5 minus 1. So 1 by 2 equal to n1 by n2. If you cross multiply, you will get it as minus 3 by 5. Okay. And now we will reform this equation. So 5 will go to the opposite side. So it will be minus 5 by 6 is equal to n1 by n2. Okay. So n1 by n2 is equal to minus 5 by 6. Now this I am going to substitute in the first equation. That is sine theta 1c is equal to n1 by n2, that is equal to minus 5 by 6. Okay. So we can write it as theta 1c is equal to sine inverse of minus 5 by 6. So this is the correct answer, but in option you don't have that. So it's a bonus question. If you attend this question, you will get the bonus points. So anyway, the answer is theta inverse of minus 5 by 6. We'll see the next question. A transparent film of refractive index 2 is coated on a glass slab of refractive index 1.45. What is the minimum thickness of a glass slab to be coated for the maximum transmission of green light of wavelength 550 nanometer? So they has maximum transmission. Maximum transmission means maximum intensity that undergoes a constructive interference. For this, we have a direct formula. The path difference is equal to 2 mu naught T, where T is the thickness of a glass slab, that is equal to their has maximum intensity constructive interference. So we can substitute as n lambda. Okay. So now we will reform this equation. We need thickness of a glass slab. So T is equal to n lambda by 2 mu naught. Okay. So just they ask maximum transmission. So we can take n is equal to 1. So we can write it as lambda by 2 mu naught. Now we will substitute the value. In the place of lambda, the value is 550 nano means 10 power minus 9 by 2 into refractive index is 2. So if you will get it as 550 by 4 into 10 power minus 9. So 550 by 4, that will be 137.5 into 10 power minus 9. So we can write it as 137.5 nanometer. So the option 3 is the right answer. Next one, this question is a previous question pattern. So we'll see the question. A thin transparent film with refractive index 1.4 is held on a circular ring of radius 1.8 centimeter. The fluid in the film evaporates such that the transmission through the film at wavelength 560 nanometer goes to the minimum every 12 seconds. So they ask minimum intensity. Assuming the film is flat on two sides, the rate of evaporation. So first we have to find the thickness of a thin film, okay, and also they have given minimum, that is minimum intensity destructive. So first we will write the formula. Path difference is equal to 2 mu naught T, okay, that is equal to, in previous question they have given maximum intensity, so we took it as n lambda. Here it is a minimum intensity, so we can write it as 2n minus 1 lambda by 2, that's all. So again we have to find the thickness. We can write it as T, that is equal to, if you substitute means 2n minus 1 lambda by, this 2 will come to the denominator, so it will become 4 mu naught. Okay, now we have to find the thickness, so that I'm going to substitute n as 1. So if you are taking n as 1 means you will get the thickness of the first fringe. So T1 is equal to, if it became 1 means 2 minus 1, 1 by 4 lambda by mu naught. Again we can substitute n as 2. If you are taking n is equal to 2, it will become 2 2s are 4. So T2 will be 2 2s are 4, 4 minus 1, 3. So 3 by 4 lambda by mu naught. Okay. So now we have to find the thickness. So we can write it as del T, that is equal to T2 minus T1. Okay. Fine. So if you subtract this means lambda by mu naught will be common. It will come out balance 3 by 4 minus 1 by 4. So it will become 2 by 4. So change in thickness is equal to lambda by mu naught into 2 by 4, which is lambda by 2 mu naught. So this is the thickness of a glass slab. So this formula I used it directly in the previous problem. So in this question I just derived. If you want, you can keep this formula directly in your mind. That is thickness of a thin film. Okay. So now we'll go for the question. They ask rate for the evaporation. So the rate of evaporation formula, that is change in volume by time t. So change in volume is area into thickness of a glass slab del T by T. Now we'll substitute the value in the place of area. Since it's a circular ring, we can take it as pi r square. So pi r square into change in thickness, that is lambda by 2 mu naught and time t. Now we'll substitute the value. We're going to keep pi as such. Into radius is 1.8 centimeter. So we'll write it as 1.8 into 10 power minus 2 the whole square. And lambda is 560 nanometer. So 560 into 10 power minus 9 by 2 into mu naught is 1.4 and time is 12. If you calculate the value, you will get it as 54 into pi into 10 power minus 13. So the answer is 54 pi into 10 power minus 13. So the answer they have given it in the form of pi into 10 power minus 13. So the answer is 54. So 54 is the right answer. Okay students, now we reach the end of the session. If you have any doubts or queries regarding this video, please do comment it. And to watch more video like this, don't forget to subscribe our channel. Thank you students.